Next is Marcos Malosetti. We already had a bit of talk about tomato and horticultural settings, and I think this is a nice expansion.
Okay, thank you. Thank you, the organizer, for this meeting. It's really a pleasure to be here. Say something about how we see this topic from vegetables perspective. I have to say, I feel at home here. Yeah, it's not only because I literally live some 500 meters from here, but actually because it's in the at Wageningen here, where I learn a lot and I work a lot here in this topic. So this is really where I really feel comfortable. And well, when Fred suggested me to present something, to share something here, I say, okay, it's a good idea and a good opportunity to bring it a perspective from the vegetable seeds. Because sometimes, you know, we have seen hearing a lot on cereals and field crop, which makes sense. Yeah, but saying it's also good to share other examples where I do see a lot of commonalities, more than just the differences. Yeah, I will bring here some. This is just a few numbers, but to make really the point about what are the challenges we have in vegetables. Yeah, it has to do with diversity. Yeah, the diversity of crops, diversity of growing areas, and that also brings complexity into the breeding process. And when it comes to the crops, just for you to have an idea, okay, what are the kind of crops we are working with, and the diversity in those crops. And that actually comes to the core of the topic here, G by E by M. So it's the G part and the M part and the environment. So, and the other thing I wanted to stress is that it's to bring it at full connection to what is the scope of this symposium. It's the third time that this symposium goes on, and it's a shame that it's just the first time I can show it here. But I fully share the vision that actually the only way to tackle this topic, this approach, is by combining different approaches. Yeah, it's not about certain areas, so it's really integrating breeding perspectives, the data analysis part, the agronomist component, and the farmers. And that is what I'm happy to have been hearing in this couple of days, and that's clearly reflected. Yeah. So in the end, what's the problem? So we have the objective is to, in the end, well, ended up with successful varieties, right? And that's the outcome from any breeding company, any breeding effort, public or private. What is then the aim is to find out high-performing and consistent crops meeting consumers' demands. And that's maybe the consumers I'm bringing it here on purpose, because in vegetables, actually, this is a very, very important component as well. And how we manage that? Well, we manage with a linear model. To a large extent, 90% of more of our decisions are based on linear models. And we try to play around with that model and try to put the focus where we can act more. So at which level can we really affect the system? Yeah? At the level of genotype, at the level of the management. That's why I'm trying here to put this with scales in size where we can actually do more. Yeah? And the environment, of course, we will have always some part of uncertainty there. That is part of also the equation that we try to extract more from that and to put it in the area that we can actually do it. And what is behind that, it's not to forget that it's really a high, complex, non-linear problem that we don't have, and we don't need to really disentangle to the very least details. So what we need to capture is from that non-linear system, alternatives that can help us pick most of the non-linearity that can help us in making better decisions. Yeah. So how we can try to tackle that? Well, let's start by the basics. So then, essentially, from a breeding perspective, it's about bringing the right germplasm. Yeah. So then, starting by bringing back the right germplasm and understanding very well the environment we're targeting to. Yeah. That actually brings the foundation to start building up in the prediction and defining system that can help us making the proper decisions. And I'm bringing here some examples. So in some cases, we do see a relatively less G by E than that. Actually, this is a good thing in the sense that actually allows to be confident in certain decisions. Well, that is always the case, but that's another story. But then the starting point is, well, building up on the proper germ plants and environmental characterization. What is the situation in vegetables? Yeah? And then we have a diversity. Yeah? And diversity in crops means diversity in biology. So in our set of crops we're looking at, the products can change very much. From, we're talking about the fruit organs in the plant. We can talk about the whole plant, like in this case here, is this pointer here, or the leaves, or even underground. So all this brings, from the biological perspective already, quite diversity. Yeah? And how the crops yield, that's another component that is very important to understand. I mean, some crops are it's just a moment of harvest of products, but other crops are actually developing that performance in time. And that's something that is quite prevalent in many of the crops in vegetables. From the point of view of genetics, again, yeah, we cannot say, well, to a large extent we're working with diploids, but also the way in which diploids are combined is also different. Then we also have some kind of some examples of polyploids. So this is only at the level of biology. When we look at the level of the agronomy, there we also have very different situations. And we can talk about tomato, but tomato can have very different situations in terms of the agronomy and the growing of the crop. So we can have open field tomato, like in this situation over here. We can have tomato mid-tech, so this greenhouse, plants are under cover, but the plants still going into the ground. But then we can have high-tech tomato, where actually the plants do not go into the ground, but actually is growing on a medium. And you can even bring it to the next level, actually, to have even the sources changes managed by lighting, for example. Yeah. But here are a few more examples from carrots, watermelon, butterhead. See here the same type of lettuce in completely different growing systems. So these are completely different environments for what perhaps even the genetics should be addressed differently. And in terms of traits, of course, sometimes I get a comment, okay, in vegetables it's not only about yield. No, yes, it's about yield. To that extent, it's about yield. But also in vegetables and yield, and when we talk about yield, is yield and everything that comes along to realize that yield. Yeah? Disease resistances and pests and so on. Yeah. But we also have to keep in mind the requirements from the industry. Yeah? But also, this is also true for feed crops. But then this is also an important component. Retailers, yeah? So that the trades that actually connect to how these products are going to consumed, and eventually the consumers, which are very, very important. Yeah, because when you enter in the supermarket, the first thing you see typically are the fruits. I mean, are the vegetables there. Yeah? And then the consumers are really driving, okay, what are the preferences and these key traits in the development. So when it comes to performance, and when we talk about predicting and using helping guiding the decision making in the process of developing new varieties and releasing new varieties, time is very important. In many crops, here I'm showing as an example okra, because you don't know the crop, I just met the crop not long ago. This yield is actually building up in time with harvests that are taken in time, and we can see here clearly very clear interactions with environment, yeah, and that environment could be many things. If it's location, it's the management in the different growing seasons, and what the decision making has to take into account is not only the total performance, but actually how that performance is distributed in time, which is also part of the element when these crops are going to fit in certain production systems. So with this. We have clear interactions, so this is not surprise. So there is ChIP-A in vegetables, there's no doubt. How we tackle that? Well, the basic statistical models, of course, are there. We can use that, and we use those. But the question is, how can we enhance those models? Yeah? How can we support better the decision making by incorporating information? That's a different type of information. That's a bit what we have been hearing in this meeting quite a few times. So, of course, what we have here as an example It's just a development as it comes in time in the conditions of a greenhouse, and just changes of the environment. That is what's causing that at the population level. This is the environmental effect. Yeah, but behind that, what is also true is that the performance of individual genotypes also is different. So this is affecting differently. The changes in the environment is affecting differently of the genotypes. Yeah, and how we can capture that to make decisions around these genotypes. Well, we can do that by bringing genetic information, of course. We've seen plenty of examples here. We can incorporate environmental information as well. Also information here, and then also management information. So how we do that? That's a key question, and that's actually the challenge, and at the same time the opportunity on how to do this. Yeah, so it has to be an integrative approach. Yeah, we have to bring it different angles to the same problem to have to see how we can more smartly combine all this information. Yeah. So this is a little bit of how I'd like to close this. I know it's not bringing any answer to the questions, more bringing the questions forward. It's okay, how we can do this, because it's easier to say than to do it. Yeah, so to implement this. Yeah, and there are plenty of good ideas how we can approach it in a smart way, and knowing the limitations we have. Yeah, so on the one hand, there's no doubt that this is a data-driven approach. Yeah. But the question is which type of data, which is the right type of data. Yeah, and we had examples this morning, for example, on that, on yesterday, as well as some examples where, okay, we can increase the amount of information and try to dump all that information into prediction machineries. Well, that's the best way to do. That's the kind of questions that I think in this community we can have good discussions about it, and we had already good discussions about this. Yeah, so I think the opportunities, as it's in bringing different angles to the same problem, it's more not competing between approaches, but actually finding the synergies between those approaches, keeping in mind the limitations. Yeah, for example, the amount of information. Let's not assume the amount of information is infinite, because it's not. It's quite limited. Yeah, always we are trying to predict what's going to happen, and actually the amount of information we have, it's not that much, and that's part of the reality. And we have to find out how we can leverage as much as possible the available information we have. And again, to close, I would like to bring it again that the way is really to bring different angles to the same problem. So from the biology, from the crop physiology, the agronomy, the breeding perspective, data analysis, and the like. And with this, I think I will let it there. Maybe I catch up with time. Okay, yeah. Yeah.